Okay, this is number 6 on the practice test. And it says the average student loan is reported to be $25,235. A student believes that the student loan debt is higher in her area. She takes a random sample of 100 students in her area and determines the mean is 27,524 and the standard deviation is 6,000. Is there sufficient evidence to support the claim at a 5% level of 5% significance level? So first of all, the thing that we have to ask ourselves with these problems, is this a mean problem? Are we trying to figure out if the mean went up or down? Or are we trying to find out if is a proportion problem? Because those are the only two types of problems that we are going to be faced with in this test. So what do you think, Michelle? Is this a mean problem or is this a proportion problem?
Yeah, it's a mean problem.
It's a mean problem. What word in there like made it gave you that idea?
The average student.
Yeah, exactly. The average is another word for mean.
Yeah. But if I didn't want to think about it, it also just says the null hypothesis mean is equal to.
Oh yeah.
But I read it and it's the average, so it told me right away it was a mean. But yeah.
Yeah, and if that, yeah, you're right. If that didn't give it away, then they're using the symbol that we have to use for mean, this mu value. That would have given it away that this is a mean problem. Yep. So then they say determine the null alternative hypothesis. So like I said, I feel like the best idea is to always identify the alternative first, because it's going to have actual language. They can't get around it. They've got to have the words like more than, less than, decreased, increased. They have to have a word like that in there directly related to the alternative hypothesis. So and to be honest, some problems like this are a little bit confusing because they state the alternative hypothesis as being like, they say, is this equal? Are they equal? And you're like, I can't have equal in the alternative hypothesis. But what you do is you just put not equal. So if ever situation, yeah. So, and okay. So what about this problem? So what's the alternative hypothesis?
It's greater than, because the number that she takes the random sample of 100 and determines the mean to be 27,000. So it's greater than 25, which is the original.
That is a good thought. That's really good thinking, actually, because if we're trying to prove the mean is larger, why would they bring a sample, right, where their mean is smaller than that? Then way to prove your point, guys. We're not proving the point at all very well right now. That would be evidence against what you're trying to claim. So that you have a really good. I will tell you that a few of the problems I kind of upset because a few of these problems actually didn't do that. What you're saying, they didn't. The mean here, the mean. They were like, oh, look, I'm trying to prove that the mean is higher than 25,000. And then they came with the sample evidence and the sample evidence was like 22,000 or whatever. I was really annoyed. I emailed the teacher like, this would never happen in real life. Why are you giving the students this problem? Are you just trying to confuse them? Like, I felt really bad, but I kind of tore into her a little bit.
Yeah.
Because you are right. If these problems are written well, that you can always look at the sample. If the sample mean is larger than the given one, then this should be, on the mean larger than type of test. But I would just caution you that unfortunately, some of these problems were not written very well. So if I would use what you just used as like a secondary. If you're really unsure about what the alternative hypothesis, I would use the sample evidence and look at the sample mean as like a secondary way of finding out what type of alternative hypothesis is. But I would really, really, really rely. What am I going to say? What are we going to really rely on to find the alternative hypothesis?
The wording? I don't know. I'm waiting for the mic drop. I don't know.
It's okay. Let's read it. Like, the average student debt is reported at this number. The student believes that the student loan debt, which is the same thing that they just mentioned above, is higher in her area.
Yeah, that right there, those last few words is what initially got me thinking that, okay, the alternative is going to be higher. But then I saw the number and I was like, well, okay, it's definitely higher.
Good. And I don't really like it because, like, they could have just erased all this information. The average is higher in her area.
Yeah.
That's what they really mean there, right? Because they said, I mean, they have all these extra words. I don't know why, but like the average student, whatever, the average, whatever you're talking about, right,
Mhm.
is reported to be this. And then they said a student believes that the average, right, that the student loan debt, which is they mean the average than the student loan debt, is higher in her area. So this there for the word average, we're going to replace it with the mu.
Mhm.
And for the higher, you're gonna say larger than, if it's higher, it's larger than 25,000. So higher than that 25,000. So that, does that sound good?
Yeah.
Yeah. Okay.
Yeah.
Sometimes I feel like they're adds so many words, and I'm just like, we didn't need all those words.
Yeah.
It's just confusing us. And sometimes they'll, like, like I said, student loan debt or whatever, like I'm just like, yeah, whatever. Like I ignore the student loan words and I just say average debt or just average period.
Yeah, that's kind of how I've gotten with writing the information down. Like I don't write the whole entire word problem. I just put like average debt 25, student believes higher in her area. She samples 100, new average 27 with the standard deviation.
Good,
So-
good. And I almost think they almost made a typo here. Maybe they're just saying it again quickly, but a student believes, they should say that the average, they
Oh yeah.
average again here. The average student loan is higher. Then it would be more obvious, mean higher.
Mhm.
I don't like the fact that she just said higher. I think she should have said the average, they think it's higher than 25. And then you literally could just like word for word, what is mean mu? What is higher than? That's the alligator's mouth is like toward that number. And then, I think that would be more straightforward, but whatever. Okay.
Maybe they're trying to make you think a little extra.
Huh. Okay. So what is this number supposed to be? So it says mu higher, which is bigger. So the alligator's mouth is pointing, facing toward the mu. The average is bigger than what?
25,230.
Yes. That's exactly what we want. Yes. Mhm.
In both of them.
Yes, exactly. And then whatever number that you have put for the alternative hypothesis, so the 252, 235, that's exactly the same number that you want. You could just copy and paste it right into null, right?
Yeah.
Because those two numbers have to be exactly the same. And then these variables, the mu has to be the same as well, right?
Yeah.
Right. Okay. And like I said, like if they did let us choose, they didn't let us choose the equals here, but if they did let us choose that, we would have known the null hypothesis. It's either going to be equals, and sometimes some textbooks just teach all the null will always say equals, which I kind of prefer that.
Mhm.
But some textbooks do teach that it's equal and opposite of the alternative.
Okay. Okay.
Yeah.
Yeah. Yeah.
So we just have to look for that word higher than, more than, great, increased, or whatever it is up there. And then we have to write that in the alternative hypothesis. And then we just have to copy the number from the alternative to the null and copy the variable from the alternative to the null. And we have to make the inequality to equality or opposite of what's in an alternative. And then we got our null hypothesis. Okay, then we move on. Now they say determine the test statistic. We don't have to worry about doing that too much. When we calculate the p-value, it usually just gives us the t-statistic anyways. But so what type of, to find the t and p-value, what type of test do we have to do?
The t-test?
Yes, it's the t-test. Yep.
Okay.
For the mean problems, there are t-tests, and then for the proportion problems, it's a one prop z test. So we go to class calc, and it's a real similar situation with this TI-84 calculator. I go to stats, I go to tests. You might have to go to stats, calculate test. I'm not sure. I think you go to stats, test as well.
Mhm.
And then you choose the same thing. You scroll down until you get to t-test. If all right, so what am I supposed to put in for the mu?
So I put the 25,235.
Good, exactly. Now, I'm kind of frustrated. They should have put like mu sub 0, like that.
Okay.
I think because they were keeping with that same notation when they did the p sub 0 earlier.
Mhm.
I think because this little sub 0 is telling you as a hint that, hey, it's the p, that number, it's a number from the null hypothesis,
Mhm.
or really this alternative hypothesis, the hypothesis period. It's a number from the hypotheses. So the same thing, the population mean, that's what we're trying to find out information about, is what is the average student loan. And so that they believe it to be you said the 25,235 was it?
Yeah, 25,235.
25,235. Okay, and then what am I going to plug in for the sample mean? Let's go back to the problem.
This is where I got kind of confused. I wasn't sure. Because she tests 100 college students, but I think there's like an extra step to figure out what that. That scared me. I don't know why. Your screen scared the shit out of me.
Oh, sorry, it's just my daughter
I
coming.
just cussed. I'm sorry.
Sorry.
I'm sorry.
Like she's put her head in front of it or whatever real fast.
Yeah, I thought, I don't know what I thought. Anyway, moving on.
Oh, you probably thought that someone was like gonna try to attack me or something.
Yeah, I was like, what is happening?
Sorry. Good thing it's just my daughter. It's okay.
Okay, that was embarrassing. Anyway. Okay, so the sample size.
Sample mean. Because
Mean.
they asked me over here again, sample mean. And the correct symbol for this is X with a bar above it.
Okay.
So a hint, it is just the average or the mean that comes from the sample.
So that would be the 27?
Yeah, that's
Okay.
what a sample mean is, just the mean that comes from the sample. Yep.
Okay.
So it's a 27,524. All right, and then my computer is still asking for this S sub X, which is saying is a sample standard deviation. So what should I put in for that?
The 6,000.
Yep, the 6,000. Yep. Okay, last but not least, it's asking for an N, which they say is a sample size. So what should I
That
put?
was the 100.
The 100. Yep, they tell us sample of 100. Yep. And they give us all the p-values. This program gives you both the t statistic here right away, and so should TI-84. And there's no question, there's no reason why you should get this t-value. They only give you one of them, so you shouldn't get that t-value. I'm wrong. But then they give me 3 different p-values. One if this were what they call a left tail test, one if it was a right tail test, and one if it's a 2-tail test. Which one do we, and so to figure out which one we need here, we just look at the direction that the inequality is in the alternative hypothesis. So we go down here to the alternative hypothesis, and the arrow or the inequality is facing toward, the alligator's mouth is facing toward the left, if you want to think about it that way. The alligator's mouth is facing toward the left. So now I just have to go to the one that's facing toward the left. And so that one, the alligator's mouth facing toward the left, that one is my p-value. There we go.
Oh. I'm getting very different answers. Okay, hold on. I'm gonna do mine again. So the mean, you put in 25, 235. Oh, I see where I messed up. Okay. There we go. Okay. Fixed it.
You get the same thing?
Yeah, yeah. I forgot to change the tail for the alligator mouth thing.
Are you okay with, you think, are you confident that you know which one to choose?
Yeah, I thought I thought I clicked it, but I didn't click it.
Okay, because that one, that's a little confusing which one to choose, and I just think about which, what direction is the inequality symbol facing in the alternative hypothesis.
The part that was confusing me was where to put the 27,000, because I forgot the 27 was the sample mean. I just thought I wasn't thinking about it as the mean. I was thinking about it as like the total and not the average. And so I was like, well, shoot, we have the standard deviation, but I didn't know what the mean was, and I just forgot that that number is the mean and it's not the actual. So okay.
I think maybe, let me look at the problem again. Sometimes it does say mean here, but determine.
Yeah.
And they don't say the mean of the sample. They probably should, reiterate that this is actually the mean of the sample. But sometimes it's really weird. They'll say, they won't even use the word average, and they won't even use the word mean. They'll just say, hey, we sampled so many people. The score was this. And sometimes you have to think about it and be like, well, if you sampled this many people and you got this score, this has to be a mean value. Like, you sampled all these people, like this can't be like the total, I don't know. It can't be like the total value they added up from all the people. This must be the mean value. Sometimes I feel like, I think most of these questions, they tell you pretty clearly, but like, if sometimes I feel like there might be, I think I ran into like one question that was like, I feel like it forgot to put the mean, which they probably should have just corrected that one problem, but whatever.
Yeah, I think the way I wrote it down too, I wasn't very clear. So I think I was looking at my paper more than I was looking at the screen. Because I think if I had reread the actual problem, I would have been like, oh yeah, duh, that's the sample mean. But the way I wrote the information, so I just changed it to say sample mean instead of just the number. Anyway, okay, cool. So I got that straightened out. That was nice. Okay.
Okay. Oh, we're not quite done. Oh, I forgot. We're not quite done with this problem, but okay.
Yes.
Before we move on, let me draw the actual picture here that you guys are asked to do on the actual test. And see, they say the average, and so this is the sampling distribution of the sample mean. And remember that the mean of this distribution was actually the mean of the original distribution. So this 25,200 is the mean of the sampling distribution. And then the standard deviation was this, actually it was like the original standard deviation divided by the square root of n, but they say here we would not know that, I think. So that's why we just don't have that. We use t-distribution instead for this problem. So I can't actually do that, but it is a similar, well, we do have a mean of 235, and then what we can do is we can draw in this 27,524, which is to the right, right?
Mhm.
I don't really know exactly how far to the right, but I'm assuming it's kind of unusual, possibly, because I mean, I'm hoping it's evidence, you know, for this, it's good evidence for this case. There's gonna be a somewhat interesting problem. And then they say, what we want to find the probability that you have a sample like this or higher. So this is a right tail test. So it kind of gives you information on what side to shade from the 27,000. And so it says we should know to shade because the arrow from this inequality is facing to the right. We know to shade to the right of this. And then this area here is our p-value. It is the probability of me getting a sample like this, or as large as this, because this is considered a large sample if the mean is 25,000, as large as this or larger. And we calculate that p-value to be like 0.00001, right? I think they actually round it to, oh yeah, 0.0001. So it's actually 3 decimals. Or 3 zeros and the 1. So this shaded area under the curve is 0.00. And actually I did a bad picture, right? My picture doesn't even look very good because this looks like that area, if this all the area under the curve is one hole, this looks like more than 0.00001, you know? So like, actually my picture is pretty bad. I would say that the picture should look more like maybe the 27 is way over here. I didn't calculate, there we go. Kind of looks more like this. And so the p-value would be more like that area over here, right? And then, so just to reiterate here, the mean of this distribution is the mean coming from the null hypothesis.
Yeah.
And where the shading starts, what we used to call our lower bound, that is the sample mean. That's the value along the x-axis such that that's where the shading starts. And then the p-value, that is the area underneath this t-distribution that's after 27,524. Are you okay with that?
Yeah.
And if, you know, that's what our calculator is doing for us, it is finding this area under the curve for us. And thank God, because it would be a really tedious, really calculus. It would be, I think you use calculus to find this formula, that you actually use the formula for this curve, and you use calculus, and it's very complicated, ugly. But our calculators are able to do it real easy and fast for us. So that's the good news. But that's actually what we're doing when we do these problems. And then, so that's the picture. And then now, okay, now here's to our final results. So we have a p-value of 0.0001. Alpha was 5%. So can we compare the 5 with just the 0.001, or do we have to change them both to percent or both to decimal, or how do we compare them?
You change the alpha to a decimal.
Yeah, good, exactly. So I have to move it twice to the left, and then, so it'd be 0.05. And then now I'm comparing, right, 0.05 with 0.001. And I always ask myself, what's the question that we need to ask?
Is P greater than alpha?
Good.
I have that written down somewhere. So yeah, so if P is greater than alpha, you do not reject the original.
Value, right? And try not to say P, because then you might confuse it with, like, you know, the proportion P. Sorry, I'm trying to help you not get confused.
It's okay.
So if the P value is what?
Greater than alpha,
Then
you do not reject the null.
is that what we have in this situation?
No.
No.
So that you would, in this case, you're going to reject the null. And then in that case, there is sufficient evidence to support the claim that the loan debt is higher.
Good. Sorry, would you say there is sufficient evidence or is not sufficient evidence?
There is.
Good, exactly, because those always go along. Because, like, we're trying so hard to, when we're in the court of law, you really want to, I mean, we're taking the person to court to find justice. We want to bring evidence to make him, to prove he's guilty. And in this situation, we want to reject the null hypothesis. Otherwise, nothing's changed. We're just going to go on like life, like it was before the trial. So the only action happens if we reject that null hypothesis. So then we're like, hey, things are different than we thought they were. You know, we're not in Kansas anymore, whatever. You know, like, then we have the evidence we need and everything. So we reject the null hypothesis and we say there is sufficient evidence to support the claim that it's higher than 25,500, 2,235. Gosh, it's hard for me to say that. And then we could write when they say failed to reject. So like you said, if the p-value was greater than alpha, then it's not, then what they're telling us is this sample is pretty common if the null hypothesis is true and it's not evidence against the null hypothesis. And so we would not reject the null hypothesis. And because we're not rejecting the null hypothesis, we would say there's not sufficient evidence. Yeah, so you can rewrite, when they say fail to reject, you can think about it saying, we do not reject. And those two do not reject, and this one not sufficient evidence, those nots go together. So if you choose this one up here, then it would be force you to choose this one down there with the same knot in it. Are you okay with that? Okay. All right. I saw your thumbs up. Okay. All right. So there's our problem.
Cool. Yeah, that was it for the questions I had. I was just stumped for a little bit on the wording of the other question, and then this one I was getting the putting it into the calculator. I was putting the wrong number.
Okay.
With the right number in the wrong area.
But is there any other questions you
have? Not off of the practice test, I don't think. I think I'm good for the practice test.
Awesome. I posted some more videos, and there was 9.5 kind of videos, but I feel like it's the same kind of things that you see on a practice test of this full hypothesis test method. And I think I put 3 videos, like number 1, like 2. I'm going to post 2. I think I just made a one with 2 for 2 and 9.5, but I have like 1, 2, 3, 4 or something from 9.5 homework and be posting those videos. So if you're like, if you run, if you can view those too, if you to help you. Okay.
Nice. Perfect.
You're welcome.
Yeah, thank you.
You're welcome. Okay, stop recording.